Here we have an example of drainage on an outsloped roadway. The outward slope faces downhill and allows water to drain off of the road surface and continue flow downhill naturally. No special ditches are required for this road type. Here we have an example of an insloped road. Insloped roads allow for movement of trucks and vehicles along its surface to move faster, as the slope is pointed in towards the hillside. So when you're going around corners, it allows you to maintain speed, as your momentum will not try to carry you off of the roadway. The issue with insloped roads is that the water gets trapped on the uphill side of the road and continues flowing down the roadway unless you offer multiple places for the water to escape, such as through culverts and elaborate ditching systems. Crowned roadways are raised up from the ground on both sides and have the highest point of the road in the middle of the road, allowing water to be shed equally to either the left or the right side. You can see how the water ran into the ditches on both sides without running down the middle of the road. Let's try that again. Yep, very nice. Here we have an example of a turnout ditch. You can see it marked here with these two sticks. We have a channel running alongside the roadway here. So when water's running down the roadway, the turnout ditch acts as an off-ramp for water to travel to escape the roadway. Now this is also an example of an insloped road, so you can see a lot of water still traveled down the roadway. Probably in need of some other sort of runoff remediation techniques here as well. So here we have an example of a broad-based dip. Essentially what we've done is taken some of the material of the road on the uphill side here, we've removed it to create a little dip, and then we've placed it back on the roadway here to create a sort of enlarged speed table sort of deal. And this will essentially just kind of force the water to, start going uphill, and it'll force it off the side of the road. So let's see how that works. Very nice. Now, for some smaller forest operations, the broad-based dip may require too heavy a machinery and may be a little too complex. So another thing that you can do, and this is used in both small and large forest operations to differing scales, but for the smaller forest operations, say here in Vermont, I've seen this a few times, you essentially create a water bar, which is a ditch in this case that will funnel water off to the side of the roadway. And to not impede travel as much, we've filled it with some down timber here. Some nice logs that will not only allow the water to flow through the logs and direct it off the roadway, but it'll also, keep the traffic from impacting this water bar. So let's see how this works. In some cases, whether you have a pre-existing stream coming off of a hillside or on the landscape, or if you expect heavy rainfall events, or if you have ditches on the upslope side of a road, or something like a turnout ditch probably wouldn't work, you can end up having to put in culverts. And essentially what a culvert does is it's a tunnel that goes from one side of the road to the other, and it takes water beneath the road surface. Yeah, let's just see how it works. So here's the culvert setup that you just saw. You can see here the water starts up here, flows down, and then it goes under the culvert just like that, down the roadway, and continues on unimpeded. So the roadway, you know, cuts through the stream like this. If the stream had to make a sharp 90 degree, or in this case it wouldn't be quite 90 degree, but if it had to make a sharp angle to cross under the road, you end up getting a lot of disturbance here and probably erosion on this bank. So that's why it's important to set your culverts at a 30 degree angle to the direction of the road travel, or at least, like, you know, the shallower angle that you have with the direction of road travel, the longer the culvert's going to have to be, the more expensive it'll end up becoming as an operation as a whole. So 30 degrees is typically the recommended culvert placement to minimize length of culvert while also allowing the diversion of the stream flow to be at a minimum, because that'll end up reducing the amount of erosion here. You can see this is a consideration that I did not take into account, is erosion on the backside. So you can see at the outlet of the culvert here, we've got a lot of erosion. So you want to think about putting rocks, big boulders and stuff on the outflow of the culvert, and that'll just help with ensuring that no erosion around the roadway occurs, and just keep sediment out of the stream, unnecessary sediment.